Have you ever wondered just how vast our universe is? Well, buckle up, my friends, we're about to embark on a cosmic journey to the farthest reaches of the known universe. Imagine a universe so grand, so boundless, that it defies our human comprehension. Our universe is not only infinite but also ever-expanding. It's like a loaf of raisin bread dough, constantly rising and expanding, with each raisin representing a galaxy moving away from each other. This comparison might seem a bit out of this world, but it is one of the easiest ways to visualize this astronomical concept. Now, let's talk about galaxies. Scientists estimate that there are around 2 trillion galaxies in the observable universe. That's a 2 with 12 zeros following it. Each of these galaxies is a cosmic megacity, hosting millions, even billions of stars. Let's put it in perspective. If each of these galaxies were a grain of sand, we could fill up an Olympic-sized swimming pool. And remember, each of these grains of sand, or rather galaxies, contains countless stars, each potentially orbited by planets, moons, asteroids, and comets. The numbers are mind-boggling. It's humbling, isn't it? It makes one realize just how small we are in this grand cosmic theater. But it's not meant to belittle us, rather it should inspire us. We are part of this cosmic spectacle, a part of this infinite universe, and that's something truly marvelous. But here's a thought to ponder. If our universe is infinite and constantly expanding, what is it expanding into? What lies beyond the universe? These are questions that continue to puzzle even the brightest minds in cosmology. So the next time you gaze up at the night sky, remember, you're not just looking at stars. You're peering across vast cosmic distances into the very heart of the universe, a universe that is infinite and ever-expanding. In the grand scheme of the universe, we are but a speck of dust. What's the fastest you've ever traveled? Now imagine going 186,282 miles per second. That's the speed of light, folks. Yes, you heard me right. In the cosmic realm, light sets the pace and it's a speedster like no other. This mind-boggling rate is considered as the cosmic speed limit. Why is it the limit, you ask? Well, according to Einstein's theory of relativity, nothing can travel faster than light. It's not just a rule, it's an unbreakable law of physics. This theory has stood the test of time and countless experiments, remaining unchallenged and universally accepted. So, as we zip along this cosmic highway, remember, even if we were to reach light speed, it's still not an instant journey across the universe. Imagine this. Even at the speed of light, crossing our Milky Way galaxy would take about 100,000 years. Now, that's a road trip to remember. Scene script. From a weather forecast of diamondrain to winds that are supersonic, let's explore Neptune. Now imagine the weather person on your nightly news predicting a downpour of diamonds. Sounds ludicrous, right? Well, not if you're on Neptune. Neptune, the 8th planet from our sun, is known for its striking blue color, but it hides an even more fascinating secret. In the extreme pressure and temperature conditions deep within Neptune's atmosphere, something extraordinary happens. Methane, a gas that's abundant in the atmosphere, breaks apart into carbon and hydrogen. The intense pressure forces the carbon atoms together, creating diamonds. Yes, diamonds. Those shiny precious stones we adore here on Earth. These glittering droplets then literally rain down through the planet's atmosphere, settling around its solid core. It's a literal downpour of bling. But don't get too excited about a diamond-drenched vacation. Neptune's winds whip around at supersonic speeds, making it a less than ideal holiday spot. Who knew weather could be so precious and so deadly? Ever wondered what space sounds like? A common question, but the answer might surprise you. Unlike what we see in science fiction movies, space is not filled with dramatic explosions or roaring rockets. In fact, space is silent. Here's why. Space is a vacuum, meaning it's almost entirely empty of matter. There's no medium for sound to travel through. You see, sound is made up of waves that need to move through something, like air, water, or a solid object. This is why we can hear things on Earth, because our atmosphere carries sound waves from one place to another. But in the vast emptiness of space, there's no air or water, no medium for sound to travel through. So if you were to find yourself floating in the cosmos, you wouldn't hear a single thing. Not a peep, not a whisper, not even a distant star going supernova. In space, no one can hear you scream, or anything else for that matter. Let's talk about weight. Imagine a star so heavy, it's almost unimaginable. Now meet R13601, a celestial heavyweight that puts our sun to shame. This stellar giant isn't just 10 or even 100 times heavier than our sun. No, it's about 315 times the mass of our sun. Let's put that into perspective. Imagine if one grain of sand represented the mass of our sun. You would need a heap of sand, almost 315 grains, to represent the mass of R136A1. It's a mind-boggling thought, isn't it? But it gets even more fascinating. Despite its colossal mass, R136A1 is not a sluggish, lumbering giant. In fact, it's one of the most luminous stars in the universe, shining millions of times brighter than our sun. That's a weighty subject, isn't it? What if time didn't run at the same speed everywhere? Now, doesn't that sound like a line straight out of a science fiction novel? Yet, in the realm of astrophysics, this is not fiction but fact, a concept known as time dilation. So, let's dive right in. Time dilation is a difference in the elapsed time as measured by two observers, due to a relative velocity between them or to a difference in gravitational potential between their locations. In simpler terms, time can slow down or speed up depending on how fast you're moving or how close you are to a gravitational field. Let's start with speed. According to Einstein's special theory of relativity, the faster an object moves, the slower time passes for it. This effect is most pronounced at speeds approaching the speed of light. So, if you were to embark on a space voyage traveling at near light speed, you'd age slower compared to someone stationary on Earth. Now, let's talk about gravity. General relativity takes this concept a step further, stating that time is affected by gravity. The closer an object is to a source of gravity, like a planet or a black hole, the slower time passes. So, if you were to hang out near a black hole, not that we recommend it, your clock would tick slower compared to someone far away from the black hole. Astonishing, isn't it? Time, which we often take for granted as a constant, unchanging entity, can warp and weave based on speed and gravity. It's a concept that not only challenges our understanding of the universe, but also opens up fantastical possibilities. Remember, these aren't mere theoretical musings. Experiments with atomic clocks on airplanes and GPS satellites have confirmed these predictions of time dilation. It's one of the many ways the universe continues to astound us with its complexity and grandeur. So if you want to age slower, just travel at the speed of light near a black hole. Of course, we're still working on the practicalities of that one. But hey, it's nice to dream, isn't it? We've traveled at the speed of light, experienced diamondrain, and even played with time. It's been quite a journey through the cosmos, hasn't it? Let's take a moment to reflect on the wonders we've uncovered. We started with the sheer scale of the universe, a vast expanse that stretches beyond our comprehension. Infinity is a concept that our minds grapple with, yet it's a reality in the cosmos. The universe, in its grandeur and complexity, continues to expand into nothingness, challenging our understanding of space and time. Next, we touched on the cosmic speed limit, the speed of light, a staggering 700 million miles per hour. It's a speed that makes our earthly velocities seem like a leisurely stroll in the park. This speed isn't just a number. It forms the backbone of our understanding of physics and the universe itself. Then, we delved into the diamondrain of Neptune, a phenomenon that sounds like science fiction, but is a scientific fact. Imagine, a downpour of diamonds, precious jewels raining down from the sky. It's a testament to the diverse and often bizarre environments that exist in our universe. We also explored the silence of space, an eternal quiet that is both eerie and beautiful. Space, devoid of a medium to carry sound waves, is a realm of profound silence, a silence that is as vast as the universe itself. We marveled at the heaviest star, a celestial body so massive that it defies our understanding of stellar evolution. This star, weighing in at more than 2 times the mass of our sun, challenges our theories and invites us to rethink our understanding of the cosmos. And finally, we played with time dilation, an effect of Einstein's theory of relativity. This mind-bending concept tells us that time can stretch and contract based on speed and gravity. Space, it's vast, it's intriguing, and it's full of surprises. It's a frontier we've only just begun to explore. Who knows what other secrets it holds?